Hello, welcome again. We are solving GATE 2025 XE solid mechanics paper. Question number 84 is a simply supported beam has a circular cross section with a diameter of 20 mm, area of 314.2 mm square, area moment of inertia 7854 mm4, and a length L of 4 meters. A point load P is equal to 100 Newton X at the center and an axial load Q is equal to 20 kilonewton X through the centroidal axis as shown in the figure. The magnitude of the offset between the neutral axis and the centroidal axis at L by 2 from the left is dash mm, rounded up to 1 decimal place. So this is Q, this is Q, this is P, this is L by 2, this is L. Okay. So P will cause bending and the bending moment due to P will be at PL by 4 because reaction of this P is P by 2 and P by 2, so P by 2 into L by 2 is PL by 4, so that is the maximum bending moment which will occur at midpoint. So maximum bending moment due to P is PL by 4 and P is 100, L is 4, so it comes as 100 Newton meter or 110.3 Newton mm. Now using bending equation we can find out bending stress. So M by I is equal to sigma B by Y. So Y is the distance from neutral or from centroidal axis. It will be neutral axis if Q is not there. Okay, but now it is not neutral axis. So it is we will call it as centroidal axis. So Y is the distance from centroidal axis. Okay, so M is your 100 into 10 power 3, I is 7854 and Y is suppose Y variable. So sigma B is 100 into 10 power 3 divided by 7854 into Y. So as sigma B is, here we can see that sigma B bending stress is varying with Y. Okay, so that is the bending stress which is variable with Y. So now consider axial load. Axial load is Q and axial load is Q and stress due to Q is load by area. So load is Q is 20 kilonewton, 20,000 and area is this 314.2. Okay, so that will remain constant at each every section. Like this, it will not vary. So it will remain constant. Okay, so now the two type of stresses are acting on the cross section. One is bending, other is direct stress. So total stress at any section is given by sigma B plus sigma. Okay. So now if total stress is 0, then it will be a neutral, we have neutral axis because neutral axis is defined by no stress. So sigma B plus sigma is equal to 0 and sigma is this quantity as sigma B is this quantity. So from this we can find out Y. So Y comes out as 4.99 mm. So that is the offset between neutral axis and central axis because here we have taken the distance from central axis Y and this represents neutral axis, so Y is the distance from neutral axis of central axis. So answer is 4.98. Okay, so if there is no Q, then the central axis is the neutral axis, but Q is there, so central axis will not be neutral axis because this is also causing some stress. Okay, so when these stress due to Q and stress due to bending will equal and opposite, then the axis will be a neutral axis. So we can say summation of these two stresses, if equal to 0, will represent neutral axis. So answer is 4.99.